Right, people, welcome back. So we got question number 6 of the 2018 AQA higher tier combined chemistry paper. So let's get this party started. Now, question number 6. Group 2 metals carbonates thermally decomposes to produce a metal oxide and a gas. Give the formula of each product when calcium carbonate CaCO3 is heated. Okay, so let's have a look at this. It says that a group 2 metal carbonate, so a metal carbonate, okay, if it's on a group 2. Now, anything that is a carbonate is gonna have a CO3 attached to it. Okay, we're gonna write X because we don't know what the metal is, but we know that the carbonate is CO3. Okay, now thermally decomposes, it means that you add heat. Okay, you add heat to produce a metal oxide and a gas. So it produces a metal, and we're gonna write X because we don't know what that metal is, oxide, okay, and a gas, and we don't know what that gas is as well right now. Okay, so 6.1, give the formula for each product when calcium carbonate is heated. So if you're gonna have a metal oxide and the only metal in this formula is calcium, it has to be calcium oxide, okay? And that will be calcium oxide. Now, the reason we only need one of each of those two atoms is because oxygen is in group 6, is gonna gain 2 electrons and is gonna have a charge of -2. Okay, calcium is in group 2, which means it's gonna give away 2 electrons, which will make it have a charge of 2+. Because those charges cancel each other out, you only need 1 calcium and 1 oxygen. Okay, so your formula will be Ca and then O. Make sure that that O is a capital letter because it's a different element. Now, second one that we have there is that we need a gas. Okay, so if we look at this, the calcium has been taken away, is over here, and then one of the oxygens has also been taken away because it's over here. So what do we have left? We are going to have a C for the carbon because it's nowhere to be seen, and we have 3 oxygens, but one of them was over there, so now we only got 2 oxygens. So you guessed it, the gas is carbon dioxide. Okay, there we go, 2 marks, easy peasy. Now, question 6.2. The relative formula mass of a group 2 metal carbonate is 197. The relative atomic masses are carbon 12, oxygen is 16. Calculate the relative atomic mass of the group 2 metal in the metal carbonate. Okay, now we're going to use the a sequence of steps to be able to answer this question, and then this will help you answer every sort of question that includes a formula. And this one doesn't have a particular formula, but we can also use it just to break it down in steps. Okay, so what we got here is, okay, so this one here is information. So what information do I have? I know that the metal X, sorry, metal carbonates, so we're gonna write X for the metal because we don't know what the metal is. Okay, carbonate, we already said, is CO3. Okay, it has a relative formula mass of 197. That equals 197. So that means that when I add the mass of the metal, the mass of carbon, and the mass of the 3 oxygens, gotta give me a total of 197. Okay, now we also know that the carbon equals 12 and the oxygen equals 16. Okay, there we go. Okay, that is the information that you have. However, it also is telling us that we have 3 oxygens in there, so we're gonna times that 16 times 3, and that's gonna give us 9, and that's gonna give us 3. Okay, so in reality, the mass of the oxygen total is 39, the mass of the carbon is 12, but we don't know what the mass of the metal is, and we don't also know what the metal actually is as well, because that is part of the question itself. It's asking us to identify the metal. So this part here is your information. Okay, that is your information part. Okay, now in this case, the C stands for changing or converting units, but when we're talking about relative atomic mass units, we don't really have an exchange rate or an exchange equivalent. So we're gonna skip this step, okay? This step, we're gonna skip it. Now, for the equation, how are we going to structure this equation? So very simple. The MR of metal X, because we don't know what it is, should be the total. So when I do the substitution, easy peasy, what do I have? Sorry, that will be the equation, and at the end, that will be when we make the substitution. Okay, so this here will be your equation, and then you will have to do your substitution. So what will be my substitution? I'm going to do it straight over here. So that's going to be the mass of the metal X is going to be the total mass, which is 197. Take away the mass of the non-metal, so that's going to be 39 plus 12. That's going to give me 49. That's not 39. Right, just made that mistake over here. Just realized. Again, this is why you got to go and check your work. 6 times 3 is not 9. I was thinking about adding it for some reason. So 6 por 3, 18. So that should be 18. I carry 1. 3 times 1 is 3 plus 1 is 4. So that will be 48 plus 12. And that's going to give me a total of 60. Okay. There we go. So that's 60. So all I have to do now is 197 take away 60, and that's going to give me 137. Okay, that's going to give me 137. So the MR of the unknown metal is 137. So in here, we're going to write down our answer, 137. And all I have to do now is look for the atomic mass that has 137 in the periodic table, and that will be the metal. Now, I also know that it should be in group number 2. So I'm not going to look all over the periodic table. I just got to go straight to group number 2. Okay, so our metal will be barium. Okay. I would write it in words as well, just in case. All right, barium. That will be your 3 marks. 1 marks for making your calculation, 1 mark for your actual mass number, and then 1 mark for actually answering what the metal is. Okay. Now it's very important that you do your working out. If I had made a mistake like I did, and I did my working out, I would have received marks because of the working out, even though I made a mistake. But if I had written down my answer with no working out, then I would have got no marks whatsoever, okay? So let's go to question 6.3. Figure 8 shows the volume of gas produced when a different group 2 carbonate W is heated. Now, they are giving us a carbonate W, okay? The group 2 will be W. So let's see, you got the graph, your volume of gas being produced, and the mass of group 2 carbonate heated in grams. Okay, and then we have calculate the gradient of the line in figure 8, give you units. Okay, now how do we calculate the gradient? Okay, so first of all, we got to go that to calculate the gradient, we need to go and do, so gradient equals of height over run. Okay, so find a spot on the height and then divide it by any spot on the run. Okay, so you basically what you want to do is you want to make a triangle. Okay, now when you do this, you gotta make sure that you do it in pencil so you can rub off your mistakes. Very likely that if you are doing a lot of crossing over in your graph itself, you're not gonna get marks. Okay, so what I like to do normally, I like to find a spot where there is a little bit of a whole number. Okay, so I know that if this is 200 and that's 300, the middle bit must be 250. Okay, that must be 250. So my triangle is gonna go from that mark right there all the way down, and I can say that that will be 1.5. Okay, so my triangle essentially is looking at 0 to 1.5, and I'm just gonna remark that a little bit, 0 to 1.5, and it's gonna go all the way up to that. There you go. Now your answer is not always going to be exactly the same as if it's in the mark scheme, but they do give you a range of values that you could actually include. So in this case, my height is 150. So I'm gonna do 150 divided over the run, and the run is 1.5. So when I plug that into my calculator, sorry, I made a mistake again. It's not 150, it's 250. Thank you for letting me know. Right, so let's do this again. 250 divided by 1.5 equals 166.666 recurring, okay? So if I do 166.66, I could just do that into 167, okay? That could be my answer there and there, okay? Now, the reason why I say that they give you a range is because in the mark scheme, it's telling us you can accept any range, any answer between the values of 160 to 174, okay? What that means is that as long as you know how to do the calculation of the gradient, sometimes you might make a little bit of a mistake, or because in this case the value of the squares is very tiny, the squares are tiny, have big value, you can have a little bit of a range between them, okay? Now, I could very easily done it from here to here and done that calculation, but it has to be only what is included. So what do I mean by that? Let me do another one, okay? So let's say, for instance, I decide that my gradient is going to be on this line. So I'm gonna go from here all the way down, okay? And then over here, let me see, is that... I'm trying to follow them and do them on the line to make it easier, but you could do any triangle, okay, any triangle, and then you'll be okay, okay? Now, the reason why I'm following this up all the way is because when you do your calculation of the gradient, you only must include whatever is in the triangle. So for instance, over here, this is my shaded area, okay? That's my triangle, okay? So the height is actually only this section. It doesn't include the section at the bottom. So if I want to find out what that is, let's see. If it's going up in 50s and you got 5 squares, each one of those squares must be 10. So this is 210. So this line landed on a 210, okay? But it's not 210 because it starts from here, okay? And that must be 100. That should be 50. That should be 60. So it starts at 60. So to get the true value, what I need to do is to do 210 take away 60, and the value of this section here is actually 150. So the height that I'm actually got here is 150. Now, so in that case, I will have to write down 150 for height, okay? Now I gotta calculate the run as well, but the run is only gonna be up to this point here, okay? So to calculate my run, I gotta do, what's that, if it's going up in, so I think is that 0.5? Because if it's half, it's 2.5. Is that the half? Yeah, so that will be 1.25, but I didn't go all the way from 1.25 because that would be from 0. So I have to subtract whatever is here. This is why it's such a mission to do it this way. That's why you rather just make a big triangle where possible that gives you straight numbers. So let's see. So if this one is 0.5, that means that this half might be 0.25, and it's going up in 5, so that would be 0.30, I believe it is. Oh, is it 35? 30, 35, 40, 45, and 50. Yeah, so let's go for that there. So over here, I would have put it down 0.30. Oh, sorry, my bad. What I should have done is not 3.0 because that's what I'm taking away. So 1.25. So 1.25 take away 0.30, and that will be 0.95. So this here should be 0.95. 0.95 essentially. Okay, so now I do 150 divided by 0.95, and that gives me 157. So the gradient with these numbers would have been 157. Now if I had written out the answer, I would have not gone a mark because it's below the expected range. The range they want it to be between 160 and 174. So the reason why they give you that range is because it depends on where you do your triangle and how big you do the triangle. The only thing that I can think about right here is that some of my lines may not be straight enough. So over here I can see that it's going a little bit higher. So if I kept it a little bit lower, it would have been somewhere down here, increasing the number that we got here overall. And that is the reason why I would prefer to do the triangles as big as possible to make sure I get whole numbers rather than working with too many of steps, because they're always bound to be a mistake when the more steps you take. Okay, is height over run, and then I'm gonna substitute that 250 because that is my height, the height in red that I chose. And then you have your run, which is 1.5, and that gave us 166.66. We round that up to 167, and then your answer will be 167. But then we also need the units, and the units are going to be centimeter cubes per gram. So we have centimeter cubes per gram. There we go. That is your 3 marks right there. Okay. Question 6.4. 24 decimeter cubes of gas is produced when 1 mole of group 2 carbonate is heated. Determine the relative formula mass of the group 2 carbonate W. Use figure 8. Okay, so because it says 24 decimeter cubes, in our table we don't have 24 decimeter cubes, and this table is in centimeter cubes. So instead we're going to use 240, okay, 240. So get a ruler. Let's go from the 240 mark. Remember, we said that every single one of those squares is going to be a 0.5. So if we go to, 10, not 0.5. 0.5 is the other one. So we go there, okay, and then we trace it all the way down. Okay, that is 1 square behind, which means that that is 1.45 grams. Okay. Now that is when it's 240, okay, when it's 240, you're looking at 1.45 grams. So what we're going to do now is that we're gonna have a look at the ratios between them, okay? So what we got here is that 1 decimeter cube equals to 1,000 centimeter cubes, okay? So the question was telling us that we have 24 decimeter cubes. Okay, I forgot the cubes there. So in centimeter cubes, that will be 24,000 centimeter cubes. Okay. Now we didn't use 24,000 because our graph doesn't have 24,000. We used something that had the same, what's it called? Similar value, I would say. So we use 240 instead. So what is the ratio between it? So if I do 24,000 divided by 240, because we actually use 240 in our graph, let's see what we get. So we got 24,000 divided by 240, that gives us 100. Okay, so the ratio will be 100 to 1. Okay, so we got to do from 100. So all we got to do now is do that 100 times 100 being 1.45. So when we multiply that, we just got to move the decimal point twice to the right. So we go 1, 2, and that's going to give us 145 as our answer. Okay, and then that right there will give you your 4 marks, 145. There we go. So that is question 6 for you from the AQA Chemistry Higher Tier 2018. So click on the next video so we can have a look at question 7. See you in a minute. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.